Imagine a place shrouded in eternal darkness, miles beneath the ocean's surface. This is the Mariana Trench, the deepest scar on our planet, a realm of bizarre creatures and extreme conditions. It's a world so challenging to explore that even today, its secrets remain largely hidden. What would happen if we plunged a steel ball into this abyss? Let's find out. Our story begins back in 1875. The HMS Challenger, a pioneering vessel of its time, first identified this colossal underwater canyon. While equipped with advanced instruments for the era, they were insufficient to fully map and understand the trench's true nature. Decades later, in 1951, the HMS Challenger 2 returned, armed with an echo sounder. This time, scientists were able to obtain accurate measurements of what appeared to be the deepest point on Earth. Viewed from above, the Mariana Trench resembles a crescent-shaped scar, stretching approximately 1,500 miles in length and averaging 43 miles in width. But it's the depth that truly astounds. If you could suspend a cable from the ocean's surface to the trench's bottom, it would extend a staggering 7 miles. To put that into perspective, imagine taking Mount Everest, the world's tallest peak, and dropping it into the Mariana Trench. The summit would still be submerged by over a mile of water. The extreme depth plunges the trench into perpetual darkness. Sunlight struggles to penetrate these crushing depths. The temperature hovers just above freezing. Yet, perhaps the most formidable challenge is the immense water pressure. At the trench's deepest point, the pressure is 1,000 times greater than standard atmospheric pressure at sea level. Despite these hostile conditions, humans have dared to venture into this underwater realm. The first successful descent occurred over 60 years ago when Jacques Picard and Don Walsh piloted a submersible into the abyss. Their journey took approximately 5 hours, with a mere 20 minutes spent at the bottom. Early on, photography proved difficult. Prior to this daring expedition, many specialists believed that life couldn't possibly exist at such depths, primarily due to the extreme pressure. However, as the submersible's floodlights pierced the darkness, they revealed a flat creature, proving life could indeed thrive here. Resources are incredibly scarce in this environment. So, what kinds of creatures call the Mariana Trench home, and how do they manage to survive? Surprisingly, the trench teems with life. Some organisms rely on chemosynthesis, extracting energy from chemicals like methane or sulfur. Others, like certain fish species, prey on weaker members of the food chain. Among the most common inhabitants are xenophyophores, amphipods, and small sea cucumbers. Some have adapted by incorporating aluminum from seawater into their shells, creating a natural armor. Microbes thrive by consuming chemicals released when seawater interacts with underwater rocks. The Mariana snailfish is often considered the rock star of this deep-sea community. These small, translucent fish, ranging from 3 to 9 inches in length and lacking scales, reign as the apex predators of the trench. The existence of such formidable life in the abyss has fueled speculation, even leading some to wonder if the ancient megalodon still lurks in these depths. The megalodon, Carcharocles megalodon, was the largest and most terrifying shark ever to roam the oceans. A true apex predator of prehistoric seas. This monster, dwarfing even the largest great white sharks, has long been extinct, according to scientists. The notion that it might survive undetected in the Mariana Trench lacks credible evidence. A megalodon would need to adapt to perpetual darkness, evolving bioluminescence or massive eyes. Furthermore, its colossal size, comparable to a school bus, would demand a substantial food supply, far exceeding the meager offerings of microbes and small snailfish. So, what would happen if a steel ball were dropped into the Mariana Trench? Would it withstand the immense pressure? Let's consider the science. Assuming a solid steel ball, the pressure at the trench's bottom wouldn't be sufficient to cause permanent damage. It would take approximately 12 minutes for the ball to reach the seabed. What about the temperature difference? The temperature contrast between the surface and the trench's depths is striking. Imagine a world teeming with life, each species sculpted by the relentless hand of evolution, perfectly suited to its own niche. The ocean, a vast and enigmatic realm, holds wonders that rival anything we find on land. It's a treasure chest overflowing with the unexpected and the awe-inspiring. Let's dive in, shall we? Prepare to be amazed. Did you know that beneath the waves, there are underwater lakes and rivers? Yes, you heard correctly. Lakes and rivers flowing within the ocean itself. This seemingly impossible phenomenon occurs because of a unique blend of salt water and hydrogen sulfide. This mixture is denser than the surrounding water, allowing it to form distinct bodies that carve their own paths across the ocean floor, creating a truly surreal spectacle. Imagine witnessing such a sight, an alien landscape unfolding before your very eyes. And then there's the world's largest waterfall, a cascade of unimaginable scale, but hidden beneath the waves. We're talking about the Denmark Strait Cataract, situated in the waters between Iceland and Greenland. Plunging a staggering 11,500 feet, it utterly dwarfs even the mighty Niagara Falls. This colossal underwater waterfall is born from the density difference between cold and warm water. The frigid water, being denser, plummets into the warmer Erminger Sea, creating a breathtaking spectacle of hydrographic power. But the ocean's grandeur doesn't end there. Concealed beneath the surface lies the Earth's longest mountain range, the mid-ocean ridge. Stretching nearly 40,000 miles, it's a testament to our planet's dynamic geological processes. Astonishingly, despite its colossal size, we've explored only about 1% of this underwater mountain range. We know more about the surfaces of Mars and Venus than we do about this hidden chain. These submerged wonders serve as a potent reminder of the ocean's immense complexity and majesty, challenging our understanding of the natural world and beckoning us to explore its uncharted depths. Now let us venture deeper, where we encounter the true stars of this aquatic theater, the marine life. The ocean pulses with a biodiversity that is both breathtaking and bewildering. From the tiniest plankton to the colossal whales, each creature plays a crucial role in the intricate web of life that thrives beneath the waves. Consider the corals. These aren't just individual organisms. They're bustling metropolises of life. These underwater cities provide shelter, food, and breeding grounds for countless marine species. They are the rainforests of the sea, teeming with a vibrant kaleidoscope of life. Then there are the algae, the unsung heroes of our planet. These microscopic organisms produce approximately half of the world's oxygen through photosynthesis, a process that also absorbs carbon dioxide, playing a vital role in mitigating climate change. They are the silent guardians of our atmosphere. The ocean also shelters some of the most extraordinary creatures on Earth. Take the octopus, for instance. This highly intelligent invertebrate possesses 3 hearts, 9 brains, and the remarkable ability to instantly change both its color and texture to seamlessly blend with its surroundings. It's a master of disguise, a Houdini of the deep. Or consider the Antarctic fish, which have evolved natural antifreeze proteins to survive in the icy embrace of the Southern Ocean. These proteins prevent ice crystals from forming in their blood, enabling them to flourish in conditions that would prove lethal to most other fish. It's a testament to the power of adaptation. And let's not forget the sharks, the apex predators of the ocean. With their streamlined bodies, razor-sharp senses, and formidable jaws, they are perfectly engineered for a life of hunting in the vast expanse of the sea. Think of the great white shark, Carcharodon carchareus, a true marvel of evolutionary design. These are merely glimpses into the incredible diversity of marine life in our oceans. Each species, each individual, stands as a testament to the relentless power of evolution and the remarkable adaptability of life. The more we learn about these creatures, the more we realize how much remains to be discovered. As we descend further into the abyss, we encounter creatures that seem more at home in the realm of science fiction than in the natural world. These deep-sea denizens have adapted to survive in an environment that ranks among the most unforgiving on Earth. Consider the goblin shark, Mitsukurina ostoni, with its elongated, flattened snout and protruding jaws bristling with nail-like teeth. It's a creature seemingly plucked straight from a nightmare, yet perfectly adapted to its deep-sea existence, employing its unique jaws to snatch prey in the perpetual darkness. Then there's the fangtooth, Anoplogaster cornuta, a fish that lives up to its name, brandishing some of the largest teeth relative to its body size of any fish in the ocean. Despite its fearsome appearance, the fangtooth is relatively small and poses no threat to humans. The frilled shark, Chlamydosalacus anguineus, another deep-sea dweller, is often hailed as a living fossil due to its primitive features that have remained largely unchanged for millions of years. With its serpentine body and fringed gills, it serves as a striking reminder of the deep sea's ancient lineage. And let's not overlook the Mariana snailfish, Pseudoliparis swiri, a species that inhabits the deepest reaches of the Mariana Trench. Thriving at depths exceeding 24,000 feet, it is the deepest living fish ever documented. In this extreme environment, where the pressure is immense and the darkness absolute, life finds a way. Imagine a world of crushing pressure 1,000 times greater than what we experience at sea level. Yet even here, in this seemingly impossible environment, life persists. Behold the snailfish, a testament to the incredible adaptability of life itself. These deep-sea denizens, with their almost alien appearances and astonishing adaptations, challenge our very understanding of what life can endure. They serve as a potent reminder that even in the most hostile corners of our planet, life, against all odds, finds a way not only to survive, but to thrive. As our exploration continues, we stumble upon a surprising truth about our oceans. They are, quite literally, a gold mine. Experts estimate that a staggering 20 million tons of gold are dispersed throughout the vast expanse of the world's oceans. However, before you start envisioning yourself as an underwater treasure hunter, a crucial catch awaits. The gold isn't conveniently clustered in easily accessible nuggets or veins. Instead, it's spread incredibly thinly throughout the ocean's waters, at a concentration of approximately 13 billionths of a gram per liter of seawater. To truly grasp the scale of this, consider this. You would need to process an astonishing 50 million liters of seawater to collect a single gram of gold. That's the equivalent of emptying and refilling about 20 Olympic-sized swimming pools, all for a sliver of gold so small it would barely cover your fingertip. Even on the seafloor, where gold can accumulate in slightly higher concentrations, extraction remains a monumental challenge. The precious metal is often embedded within solid rock or mixed inextricably with other sediments, demanding extensive and disruptive mining operations for collection. And that's before even considering the immense technical hurdles and potentially devastating environmental impacts of deep-sea mining. So, while our oceans undoubtedly hold a wealth of gold, it's a resource that remains largely out of reach, at least for now. Yet, this hidden bounty serves as a captivating reminder of the sheer wealth of resources our oceans conceal, many of which are still waiting to be discovered. As we delve even further into the enigmatic depths of the ocean, let's turn our attention to a peculiar phenomenon that has baffled scientists for decades. A unique and unsettling sound known only as the bloop. Back in 1997, researchers detected an incredibly loud, ultra-low frequency sound emanating from the Pacific Ocean. The sound was so incredibly powerful that it was picked up by sensitive hydrophones nearly 3,000 miles away. This mysterious sound was quickly dubbed the bloop, and for years, its origin remained shrouded in mystery. The sound defied easy explanation. It was unlike anything researchers had ever encountered. It was far too loud to be attributed to a ship or submarine, and it didn't match any known sounds produced by marine animals. This led to a flurry of wild speculations and imaginative theories, ranging from the existence of colossal sea monsters lurking in the abyss to the presence of clandestine underwater alien bases. However, after years of dedicated investigation, scientists finally cracked the mystery of the bloop. The sound wasn't the call of a gigantic creature or the hum of an alien installation. Instead, it was revealed to be the sound of an ice quake, the thunderous cracking and breaking of a massive iceberg as it calved away from an Antarctic glacier. The sound of this colossal ice breakup traveled vast distances through the water, eventually reaching the listening devices thousands of miles away. The story of the bloop serves as a potent reminder of the countless mysteries that still lie hidden within our oceans. Even with our advanced technology and ever-growing knowledge, the ocean still holds the capacity to surprise and puzzle us. Our journey now takes us to a place as remote as it is fascinating. Point Nemo. Named in honor of Captain Nemo, the iconic character from Jules Verne's 20,000 Leagues Under the Sea, Point Nemo is the oceanic pole of inaccessibility. In simpler terms, it's the point in the ocean that lies farthest from any landmass. Located in the vast expanse of the South Pacific Ocean, Point Nemo sits approximately 1,450 nautical miles from the nearest land. To truly appreciate its isolation, consider this. The closest humans to Point Nemo are often the astronauts aboard the International Space Station, orbiting the Earth at a distance of roughly 258 miles. This extreme remoteness makes Point Nemo one of the least disturbed places on our planet, a place of profound solitude where the immensity of the ocean can truly be felt. But despite its isolation, Point Nemo isn't entirely devoid of life. Microorganisms known as extremophils, organisms that thrive in extreme conditions, can be found inhabiting its waters. Point Nemo also serves a somewhat unusual purpose. It acts as a spacecraft cemetery. Due to its remote location, space agencies around the world utilize it as a designated dumping ground for decommissioned satellites and space stations. These spacecraft, some of which may even carry traces of extraterrestrial material, eventually sink to the ocean floor, adding another layer of intrigue to this already fascinating location. Our journey now leads us to the absolute deepest point in the ocean, a place so remote and inhospitable that it has been visited by fewer people than have walked on the moon. This is the Challenger Deep, located within the Mariana Trench in the western Pacific Ocean. Named after the HMS Challenger, the British survey ship that conducted the first scientific survey of the trench in 1875, the Challenger Deep plunges to an astonishing depth of approximately 36,000 feet. That's nearly 7 miles straight down. To put that into perspective, imagine placing Mount Everest, the world's tallest mountain, at the bottom of the Challenger Deep. Its peak would still be submerged by over a mile of water. Imagine a place where the weight of the ocean above presses down with unimaginable force over 1,000 times the pressure we feel at sea level. Here, in the crushing depths of the Challenger Deep, the temperature hovers just above freezing. Yet, even in this seemingly impossible environment, life persists. Indeed, it thrives. Scientists have unveiled an astonishing array of organisms that call the Challenger Deep their home. Among them are single-celled amoebas, known scientifically as foraminifera. And then there's the Mariana snailfish, a remarkable species currently recognized as the deepest living fish ever discovered. Venturing into the Challenger Deep is no simple feat. The sheer pressure, the frigid temperatures, and the impenetrable darkness create a formidable and perilous environment to navigate. But these immense challenges have only fueled our determination to explore this Earth's final frontier. From the pioneering descent of the Trieste bathyscaphe in 1960 to the more recent expeditions employing autonomous underwater vehicles, our quest to explore and understand the deepest recesses of our oceans continues. The Challenger Deep stands as a stark testament to the extreme conditions that life on Earth can endure. It's a potent reminder of how much remains to be discovered about our own planet. As we plunge deeper into the ocean's mysteries, we encounter life forms that have miraculously adapted to survive in some of the most hostile environments imaginable. These extremophils, as they are known, challenge the very limits of our understanding of life itself. They even hint at the tantalizing possibility of life existing beyond our own world. Consider, for instance, the bacteria that flourish near hydrothermal vents on the ocean floor. In these seemingly uninhabitable places, where the water is superheated and the pressure is crushing, these microorganisms not only survive, but thrive. They have evolved a remarkable ability to utilize the chemicals spewing from the vents, such as sulfur and methane, to generate energy in a process known as chemosynthesis. A process akin to plants using sunlight, but fueled by the Earth's own heat. And then there are the organisms that call the Challenger Deep home. Here, in the pitch-black abyss, under pressures 1,000 times greater than at sea level, life has carved out a niche. From single-celled amoebas to the elusive Mariana snailfish, Pseudoleparus swirei, These creatures have adapted to survive in an environment that would prove lethal to almost all other forms of life. These extremophiles hold immense interest for scientists, not only for what they can teach us about the resilience of life on Earth, but also for what they might reveal about the potential for life on other planets. If life can thrive in the extreme conditions of the deep sea, could it also exist in the icy oceans of Jupiter's moon Europa, or perhaps even beneath the frigid surface of Mars? As we continue our journey through the ocean's depths, it's vital to recognize the incredible tools and technologies that make our exploration possible. These devices, meticulously engineered to withstand the extreme conditions of the deep sea, allow us to venture where humans cannot go, unveiling the mysteries of the ocean one at a time. One such tool is the deep-sea submersible. These vehicles, which can be manned or unmanned, are designed to withstand the immense pressure of the deep sea. They are equipped with powerful lights to pierce the inky darkness and cameras to capture images and videos of the alien world below. The Trieste, which reached the bottom of the Challenger Deep in 1960, and the Deep Sea Challenger, which repeated the feat in 2012, stand as prime examples of manned submersibles pushing the boundaries of exploration. Then there are the remotely operated vehicles, or ROVs. These robotic explorers are controlled from a ship on the surface via a tether. ROVs can remain underwater for far longer than manned submersibles, making them invaluable for detailed scientific research and exploration. They are equipped with robotic arms to collect samples and high-definition cameras to document their findings, transmitting images of bizarre creatures back to the surface. Autonomous underwater vehicles, or AUVs, such as the Nereus, represent another crucial tool for deep-sea exploration. These vehicles can operate independently, without a tether to the surface, allowing them to explore areas that are difficult or impossible to reach with other methods. They employ advanced navigation systems to move through the water and can be equipped with a variety of scientific instruments to collect data, painting a comprehensive picture of the deep-sea environment. These tools, coupled with advancements in sonar mapping and satellite technology, have revolutionized our understanding of the ocean. They have allowed us to explore deeper and with greater precision than ever before, revealing a world that was once completely hidden from our view. As our journey draws to a close, we are left with a profound sense of awe and wonder at the sheer vastness and complexity of our oceans. We've journeyed from the sunlit surface to the darkest depths, encountering along the way a world teeming with life and filled with mysteries yet to be solved. We've learned about the immense pressures and frigid temperatures that define the deep sea, and the remarkable creatures that have adapted to thrive in these extreme conditions. We've even discovered underwater lakes and rivers hidden beneath the waves. Imagine a world hidden beneath the waves, concealing the mightiest waterfall and the most expansive mountain range. We've marveled at the incredible tapestry of marine life, from the minuscule plankton to the colossal whale, each playing a vital role in our planet's delicate ecosystem. We've also explored the formidable challenges of venturing into this last unexplored frontier on Earth. The deep sea is a realm of harsh realities, demanding immense ingenuity and courage to penetrate its inky depths. But as we've witnessed, the rewards are immeasurable. Every new discovery brings us closer to a deeper understanding of our planet and our place within its grand design. As we draw this journey to a close, let us remember that our exploration of the ocean is far from complete. Countless mysteries remain veiled, awaiting revelation, countless species yet to be discovered, and daunting challenges to overcome. The ocean, with its boundless expanse and unfathomable depths, serves as a constant reminder of the infinite possibilities that lie before us. It beckons us to continue our quest for knowledge, to delve deeper into the unknown, and to forever marvel at the wonders of our blue planet. Thank you for accompanying us on this incredible voyage. Until next time, keep exploring, keep questioning, and keep marveling at the wonders that surround us. Now, let us descend into the Mariana Trench, the deepest and perhaps most enigmatic abyss on Earth. Bizarre creatures lurk here, denizens of the deep, like the anglerfish with its bioluminescent lure, the archaic frilled shark, the grotesque goblin shark, the barrel-eye fish with its transparent head, and the menacing hatchetfish. They dwell within this crescent-shaped scar in the western Pacific. Only a handful of brave souls have ever plumbed the depths of the Challenger Deep, the Mariana Trench's southern extremity. At nearly 36,000 feet below the surface, vents spew forth carbon dioxide and liquid sulfur, while mud volcanoes erupt under pressures 1,000 times greater than at sea level. It is a place of otherworldly extremes. But fear not, for we are about to embark on a journey to places no less mysterious and unsettling than the Mariana Trench itself. Our first stop, Mexico's Yucatan Peninsula. Behold the cenotes, those bottomless sinkholes brimming with crystalline water. This is freshwater overlaying saltwater, seeping in from the distant sea. The ancient Mayans revered these natural wells as gateways to Xibalba, the underworld. Thousands of cenotes, formed by the collapse of the limestone bedrock, intertwine to create one of the world's most extensive underwater cave systems. Within this labyrinthine network, disorientation can quickly become your unwelcome companion. Next, we journey to the Caribbean, descending almost 8,000 feet to witness the Von Dam vent field. Here, hydrothermal vents unleash torrents of scalding muddy water, reaching temperatures of 400 degrees Fahrenheit, hot enough to bake a pizza. These mounds are composed of talc, the very substance found in baby powder. The Von Dam vent field serves as an oasis for bizarre species, including a peculiar eyeless shrimp equipped instead with patches of light-sensitive cells along its back. Our next enigma lies not far away, still within the embrace of the Caribbean, just off the coast of Belize. Here lies the Great Blue Hole, a colossal sinkhole approximately 1,000 feet in diameter and plunging to depths exceeding 400 feet. Long ago, this was a cavern, until rising sea levels flooded it, causing its roof to collapse. As you descend into the Great Blue Hole's crystalline depths, darkness descends with you. Stalactite-filled caves beckon, but beware. Entering them risks becoming hopelessly lost within their intricate embrace. At a depth of approximately 50 feet, the water shimmers, marking the invisible boundary between the sinkhole's salty upper layer and the freshwater abyss below. It's time to ascend, for who knows what lurks in those murky depths. Our next destination lies off the Pacific Northwest coast. Here, scientists discovered nearly 500 streams of methane bubbles rising from the seabed. These vents have been dubbed champagne seeps, a far more appealing name than fart spas. Scientists continue to grapple with this phenomenon. Where does this methane originate? Is the underwater temperature warmer than the surrounding ocean? And, most importantly, what would happen if one were to ignite a methane bubble near a large plume? Methane, a highly flammable gas, would create a spectacular, if dangerous, display. Finally, we venture to Iceland to dive into Silfra, a fissure filled with the purest glacial water. This 200-foot deep chasm is the only place on Earth where divers can simultaneously touch two continental plates. As you descend, the rocky landscape transforms into an otherworldly vista. Divers who dare to explore this incredible place risk equipment malfunctions due to the frigid temperatures and the ever-present threat of hypothermia. Imagine a world where icy waters hold secrets to life unlike anything we've ever seen. But first, a slight detour. Our journey begins not in the prehistoric past, but in a modern-day chill, a place where even survival seems impossible. Forget about surviving. In the waters off Fisher, where the temperature hovers around a bone-chilling 35 degrees year-round. Next stop, Scotland. Picture this. The skirl of bagpipes echoing across the rugged highlands. Now plunge beneath the waves into the Gulf of Corryvreckan, a narrow strait squeezed between two islands. Here lies a spectacle of raw, untamed power. Massive underwater rocks and yawning chasms that together create the world's third-largest permanent whirlpool, the Corryvreckan Maelstrom. The water surges through the strait at breakneck speed, colliding with the submerged rocks in a furious dance. It's a scene of utter chaos, like a gigantic pot of boiling water. Waves, some reaching a staggering 15 feet in height, erupt from the churning depths. You can hear the roar of this aquatic beast from 10 miles away. For centuries, the Corryvreckan Maelstrom has been a watery grave, swallowing countless sailors caught unawares by its savage power. In the blink of an eye, ships were dragged under, disappearing without a trace. Now, let's leave the bagpipes behind for an even more extreme adventure. We're heading to Antarctica, to the Southern Ocean, and the raw sea ice shelf. This colossal ice sheet, roughly the size of Spain, conceals an ocean beneath, containing as much water as the entire North Sea. Imagine the astonishment of scientists when, after drilling through this frozen behemoth, they discovered life thriving in such an extreme environment. They stumbled upon dozens of mysterious species, creatures never before seen by human eyes. Most unnerving were the upside-down swimming fish and overturned sea anemones, clinging to life in the frigid waters. Hopefully, bizarre places with a notorious reputation don't frighten you. Because next, we are visiting the Bermuda Triangle. This infamous patch of ocean, nestled between Bermuda, Florida, and Puerto Rico, is a place where planes and ships seem to vanish into thin air. The mystery first captured the world's attention in 1945, when 5 U.S. Navy planes disappeared during a training mission. Just before radio contact was lost, the flight leader reported, "We're entering white water. Nothing seems right." After that, the planes, with 14 men aboard, vanished. Even more chilling, a rescue plane with 13 people on board also disappeared. Some believe the mythical city of Atlantis lies at the bottom of the triangle, its inhabitants using extraterrestrial technologies to sink ships and crash airplanes. Others attribute the disappearances to rare and unexplored natural phenomena, such as magnetic anomalies or massive pockets of flammable methane gas. If a bolt of lightning ignited a giant methane bubble near a ship or plane, it could potentially sink it without a trace. But methane is found everywhere, and it never behaves this way. Some experts aren't even sure there's a mystery to explain. Lots of busy routes pass through this area. No wonder more ships and planes sink there than anywhere else. Now, bundle up in some warm clothes. We're heading north again, to Cape Desolation in Greenland. A truly inviting name. In 2012, Canadian researchers were sampling the water in that area when their equipment returned to the surface with pieces of coral attached. That's how they stumbled upon a cold water coral reef. These unique pinkish corals can thrive without sunlight and live in strong currents 3,000 feet below the surface. Another unique spot you can't miss lies between Greenland and Siberia, the Gakkel Ridge. This is the deepest and most remote portion of the global mid-ocean ridge system. In some places, it plunges to depths of more than 3 miles. It's only natural that the darkest corners of this underwater world remain unexplored. Here, fascinating chemical reactions produce hot, mineral-rich fluids that spew from seafloor vents. Because these vents are isolated from the rest of the ocean, they are hotspots for bizarre creatures found nowhere else on Earth. Our next stop is just off the coast of Cuba. Circular columns, paved floors, symmetrical stone structures. That's what the Cuban underwater city looks like. What happened here? Why was a large city abandoned at a depth of more than 2,000 feet? Many believe these are the ruins of a long-forgotten civilization. But scientists have their doubts. They claim the lost city is nothing but a natural phenomenon that appeared about 5 million years ago. The disk and donut structures often appear around areas of the seafloor where natural gases break free. Speaking of gases, when you come to visit the Sargasso Sea in the middle of the North Atlantic Ocean, you won't find any shores. Instead, it's surrounded by powerful ocean currents. These are the same. Imagine a vast ocean where powerful currents sculpt the waters into a colossal gathering of thick, brown seaweed. Picture the 19th century, a French ship adrift in the Sargasso Sea. Its sails are raised, as if ready for a journey, yet the vessel is eerily deserted, devoid of a single soul. This bewildering vanishing act fueled chilling tales of carnivorous seaweed, a sinister trap for unsuspecting sailors. The Sargasso Sea, a truly strange and unsettling realm. An unnatural serenity blankets its surface, the water strangely warm, defying the tumultuous, icy grip of the surrounding Atlantic Ocean. Could such a bizarre sanctuary become the haven for the largest marine predator ever to roam the Earth? The megalodon, Carcharochel's megalodon. Consider the evidence. Colossal teeth, some exceeding the size of a grown man's hand, unearthed from every corner of the globe. These relics whisper of a creature that favored the sun-drenched, shallow coastal waters of nearly every continent, save for the frigid expanse of Antarctica. Therefore, a quest for this leviathan in the crushing depths of the Mariana Trench, the icy fjords of Greenland, or the cenotes of Mexico would be a futile endeavor. But could the warm embrace of the Caribbean offer a refuge, a place to elude the relentless march of the modern world? Do not let your imagination run wild just yet. The truth is stark. There is no concrete proof that Megalodon still exists in our time. This was no timid, reclusive creature. And yet no credible sighting of this immense shark has emerged, not even near the infamous fart spa. A rather ignominious end for a legend. The oceans for now remain silent on the Megalodon's fate. Imagine a steel ball plunged into the crushing depths of the Mariana Trench. At a temperature of 86 graus, the immense pressure would cause a slight compression, a mere shrinking of its form. Yet, as the ball ascended, returning to the surface, it would regain its original shape, as if the abyss had never touched it. But what if it became trapped down there, in that lightless realm? Would the relentless corrosion of the deep claim it? The corrosion of steel is a patient, insidious process, its pace dictated by the availability of oxygen. And in the inky blackness beyond 3 miles deep, the amount of dissolved oxygen remains remarkably constant. Calculations reveal a staggering truth. It would take over 10,000 years for the steel ball to completely succumb to rust in this underwater graveyard. But what of us? What would it take for humanity to venture into such an extreme environment and survive? Let's consider the tools of past explorations, chief among them a remarkable substance called syntactic foam. Why syntactic foam? Because it is uniquely suited to both float and withstand the unimaginable pressures at these depths. Without such protection, our lungs would be instantly crushed, the water pressure forcing fluid into our mouths, replacing precious oxygen with the cold, suffocating embrace of the sea. And then there's the equally vital issue of ascent. Should disaster strike, a rapid return to the surface is paramount. One deep-diving vessel employed a clever system. 1,000-pound steel weights, tethered by a specialized wire designed to corrode in seawater within 11 to 13 hours. A failsafe, ensuring a swift escape from the trench's grasp. Oxygen, of course, is paramount. Any future expedition to the Mariana Trench must prioritize air recycling technology, drastically reducing the amount of oxygen that needs to be transported into the abyss. Finally, there's the inescapable problem of electricity. No power outlets exist in this alien world. Any submersible must carry sufficient battery power to support every vital system: communication, oxygen recycling, lighting, and scientific instruments. These challenges, once seemingly insurmountable, are now yielding to human ingenuity. As recently as 2020, a commercial tour of the Mariana Trench became a reality. 3 fortunate individuals were encased within a 3.5-inch thick titanium sphere, shielded from the crushing pressure and physiological stresses of the deep. Each guest embarked on a solo journey, a 14-hour odyssey into the unknown. The descent alone consumed over 4 hours. Upon reaching the seabed, they were granted a glimpse of the bizarre and extraordinary creatures that call this realm home. Then, the long 4-hour ascent back to the world of sunlight began. Now, prepare yourself. Imagine donning your flippers, for we are about to embark on a journey to the deepest point on Earth. The bottom of the Mariana Trench awaits. Plunge into the water with me. 1 foot underwater. This is the depth to which you can safely swim, without any specialized equipment, no mask, no fins. Look around. Are those tourists? Perhaps a pod of whales. 10 feet underwater. This is deeper than most public swimming pools and beaches in the United States. Gaze upon the colorful fish, the vibrant photoplankton feeding on the sun's filtered rays. 26 feet down. Here lies the foundation of Venice, the floating city of Italy. Centuries ago, builders laid the first columns at this depth, upon which they would construct houses and streets. 30 feet underwater. Here the pressure begins to assert itself. At the surface, you experience atmospheric pressure, roughly 15 pounds per square inch. But at 30 feet, that pressure doubles. The air pockets within your body, lungs, ears, begin to compress, causing discomfort. But fear not. Your organs are resilient, elastic. You can continue your descent. 40 feet underwater. You're running out of air. The average person can hold their breath for 30 to 90 seconds. The current record, however, is an astonishing 24 minutes and 37 seconds. Take a breath. You'll need diving equipment to continue. There you go. Thank you very much. Tourists often dive to this depth to explore reefs and corals. No special skills are required, but any deeper, and you'll need training and a license. 45 feet down. Be cautious. Sharks patrol these waters, searching for prey. Sometimes tourists descend to this depth in protective cages, hoping to catch a glimpse of these apex predators. It's best to keep your distance, avoid attracting their attention. Leave the shiny jewelry at home. Sharks are drawn to such things. 62 feet underwater. Here, if you were in Florida, you would find the Aquarius Reef Base Lab. An entire building with rooms for exploring the seafloor, accessible via a hatch. Imagine descending into the crushing depths of the ocean, a journey into an alien world far removed from the sunlit surface. We begin our descent, and at 105 feet, a ghostly artifact appears. An antique diving bell suspended from a chain. Picture divers of centuries past lowered into the depths within these bells, relying on the trapped air to explore the mysteries below. They sought sunken galleons laden with treasure. Deeper still, at 140 feet, a breathtaking sight awaits. In Qiandao Lake, China, an entire submerged city slumbers. Streets, houses, and temples perfectly preserved, a testament to a forgotten time. Plunging further, at 330 feet, a behemoth appears. A colossal blue whale, nearly the length of 2 train cars, dwarfs our vessel. These gentle giants often descend to these depths. Let's pause and listen to their haunting songs, a symphony of the deep. But the journey continues. At 660 feet, the sun's embrace weakens. This is where much of the ocean's vibrant life begins to fade. Below, bizarre creatures lurk, like the anglerfish. Its bioluminescent lure, a macabre beacon in the abyss, is an adaptation to the immense pressure and perpetual darkness. At 702 feet, we reach the limit of human endurance without specialized equipment. Here lies the record of the deepest man on Earth, the only individual to reach this depth unaided. The pressure he endured was 20 times greater than at the surface. An unfathomable feat of human will. Suddenly, at 985 feet, a mechanical growl echoes through the water. A submarine. These vessels, built to withstand immense pressure, can reach these depths, traveling at speeds of 20 to 26 km/h. Ironically, an ostrich, capable of running twice as fast, is utterly helpless in this environment. At 1,970 feet, we bid farewell to the scuba diver. The world record for scuba diving was set in the Red Sea. The descent took a mere 12 minutes, but the ascent, a grueling 15 hours. A testament to the dangers of decompression sickness. Now we enter an atmospheric deep diving suit, a technological marvel that shields us from the crushing pressure. At 2,454 feet, consider this. If the Empire State Building were submerged, its tip would be at this level, the observation deck flooded, the carpet soaked. Deeper still, at 2,300 feet, the pressure intensifies, 70 times greater than at the surface. The plastic components of our suit begin to creak and groan under the strain. An urgent delivery arrives, an ultra-deep submersible, our ticket to the true abyss. At 2,770 feet, the tip of the Burj Khalifa, the tallest building on Earth, would be visible. The scale is staggering. Reaching 5,287 feet, we are at the depth of Lake Baikal, one of the oldest and deepest lakes in the world, its area exceeding that of Belgium. At 8,040 feet, the record depth of the Perdido oil platform in the Gulf of Mexico. Its above-water structure, with its 3 decks, nearly rivals the height of the Eiffel Tower. We plunge into the inky blackness of the Atlantic Ocean, reaching an average depth of 11,963 feet. A massive cable as thick as a giraffe's neck stretches endlessly into the gloom. This is a transatlantic cable, once used for telegraph communications between Europe and North America. Suddenly, at 12,533 feet, a ghostly silhouette emerges from the darkness. It's the Titanic. The immense pressure here would instantly crush a human. Only a submersible can withstand these conditions, allowing us to witness the tragic majesty of the sunken liner. At 13,123 feet, we reach the end of the deepest mine in the world, the Maponing gold mine in South Africa. But the ocean's depths still beckon. Accelerating our descent, we arrive at 20,000 feet. Here lies the wreckage of the USS Johnston, a destroyer sunk over 70 years ago. The number 557 is still visible on its bow, a poignant reminder of the sailors who perished here. Deeper, at 26,200 feet, we encounter the Mariana snailfish, Pseudoleparis swiri, the deepest dwelling fish in the world. These creatures, about the size of a domestic kitten, possess almost transparent skin and poorly developed eyes, adapted to a world devoid of sunlight. At 29,030 feet, imagine Mount Everest, inverted and plunged into the Mariana Trench. Its peak would still be far above us. Finally, at 35,745 feet, we reach the Challenger Deep, the deepest known point in the ocean. Even here, life persists. Under a microscope, we discover bacteria feeding on organic molecules, similar to oil. A final descent, and at 36,070 feet, we touch bottom. The pressure here is a staggering 1,071 times greater than at the surface. But we are not the first. In 2012, filmmaker James Cameron descended in a specially designed submersible. The pressure damaged the vessel, impairing its maneuverability and sonar. Despite the challenges, he spent 3 hours exploring the Challenger Deep, capturing images of this alien realm. Look closely at the seabed. Bubbles rise from the depths, a mixture of carbon dioxide and liquid sulfur, a testament to the extreme geological forces at play in this hidden world. It's a freezing hell down here. Imagine a place of crushing pressure and near-freezing temperatures, a realm where sunlight never penetrates. Yet even here, life clings on. We find ourselves in the Mariana Trench, the deepest part of our planet's oceans, where existence is a constant struggle. Here, in these extreme conditions, a few hardy microorganisms manage to survive. Xenophores, amphipods, and small sea cucumbers are among the most common inhabitants. Their numbers are sparse, dictated by the scarcity of food. Typically, palm leaves that fall into the ocean eventually sink and provide sustenance to the deep-sea creatures. But the Mariana Trench lies a staggering 124 miles from the nearest islands. The only source of nourishment here is the detritus of the upper ocean layers. Ancient plankton and discarded fish scales. This meager fare must descend tens of thousands of feet to become a meal for the bottom dwellers. But what if we could delve even deeper, venturing into the Earth's very crust? Picture a colossal drill, its bit glowing red-hot, jet engines roaring as it bores relentlessly downward. We plunge another 36 miles through solid rock until finally we reach the edge, the upper mantle. Before us lies an ocean of molten lava, stretching down a further 1,800 miles. We must navigate this searing expanse, swimming through the liquid rock, until we arrive at the outer core, another 1,400 miles deep. Finally, we reach the inner core, a solid sphere 705 miles in radius. Congratulations, we have arrived at the very center of the Earth. Now, the daunting question, how do we get back out? Perhaps a less harrowing adventure is in order. How about a high five with a sea creature? Let's turn our attention to the Tasmanian red handfish, Brachyonychthys hirsutus. Unlike other fish, this peculiar creature doesn't swim, it walks. Using its modified flipper-like pectoral fins as hands, it strolls along the ocean floor. These bottom walkers are easily disturbed by swimmers and boats, and sadly, some people even try to keep them as pets. A far better option is to simply give them a respectful wave and continue on our way. Next, we encounter the vampire squid, Vampirotuthis infernalis. Its very name, translating to vampire squid from hell, is meant to inspire terror. With its dark red coloration, spiky appendages, and the unsettling ability to seemingly turn itself inside out, it certainly looks the part. The vampire squid seems to be a terrifying predator, but its bark is worse than its bite. It's about as harmless to humans as a kitten. It's as if Dracula tried to scare you, but it turns out he has no blood-sucking fangs. The vampire squid feeds on marine snow, a mixture of dead plankton, fecal pellets, and other organic debris that drifts down from the surface. Since it's not a predator, it relies on impressive defensive strategies. Its vampiric appearance is designed to deter larger creatures that might consider it a meal. Turning itself inside out exposes the spiky inner skin, making it appear more intimidating. It can also eject a cloud of bioluminescent mucus, a dazzling display of light designed to confuse and distract potential predators. Now, imagine taking a relaxing boat trip off the coast of Mexico. The sun is shining, the water is a brilliant blue, the perfect vacation. But then you remember the most endangered marine mammal in the world lives here. We are talking about the vaquita, Phocoena sinus. The vaquita is not dangerous, but don't expect a close encounter. This shy little porpoise, whose name means little cow in Spanish, is a tiny sea mammal with distinctive black markings around its eyes, resembling a sea panda. Seeing one would be an incredibly rare and special experience. Tragically, they are on the very brink of extinction, primarily due to accidental entanglement in fishing nets. It's estimated that only around 10 individuals remain in the wild. Finally, let's observe a creature that seems straight out of a fantasy film, the blue dragon, Glaucus atlanticus. This striking sea slug, also known as the blue angel, can be found in the Atlantic, Pacific, and Indian Oceans. This tiny mollusk only grows to about an inch in length. What appears to be its back is actually its vibrant blue underbelly. It floats upside down, allowing its blue coloration to camouflage it against the surface of the water. But the blue dragon is not just a pretty face, it's also a cunning predator. It primarily feeds on Portuguese man-of-wars, Physalia physalis, also known as bluebottles. Remarkably, the blue dragon stores the stinging nematocysts from the man-of-war in specialized sacs for later use. In essence, it steals their defensive mechanisms. When threatened, the blue dragon releases these stored stinging cells, directing them at its attacker with even greater force than the Portuguese man-of-war could have mustered. Because they can store such a high concentration of stinging cells, they can pose a threat to humans. Therefore, if you encounter one, admire it from a distance and avoid handling it. Lastly, let's marvel at the barrel-eye fish, Macropinna microstoma. Looking at this fish, one might feel as if they've suddenly gained Superman's X-ray vision. The barrel-eye possesses a transparent head, allowing you to see its eyes and brain in astonishing detail. This remarkable creature inhabits the deep sea, the lowest levels of the ocean, where bizarre life forms thrive in near-freezing temperatures and perpetual darkness. They endure water pressure almost 1,000 times greater than at the surface. If the thought of the deep sea sends shivers down your spine, you're not alone. It's a realm of mystery and extreme conditions, where the struggle for survival is constant. Let's plunge into the depths and uncover some of the ocean's strangest inhabitants. First, consider the barrel-eye fish, Macropinna microstoma. This denizen of the Atlantic, Pacific, and Indian Oceans boasts a truly remarkable feature, a transparent head. Imagine the initial confusion when this species was first described in 1939. Scientists initially believed its eyes were fixed, offering only tunnel vision. However, Bruce Robinson and Kim Reisenbichler from the Monterey Bay Aquarium Research Institute made a startling discovery. The barrel-eye fish can rotate its eyes vertically within its transparent head, allowing it to scan the waters above for predators or unsuspecting prey. This transparent dome also maximizes light capture, enhancing its ability to spot potential meals in the dim depths. It's believed that the barrel-eye fish primarily feeds on jellyfish and smaller fish. Now, picture yourself diving into the ocean at night. If you're fortunate, you might witness a breathtaking display. the orange ball corallimorph blooming in the darkness. But be quick! The moment a flashlight beam pierces the gloom, it will retract its delicate tentacles. Our journey now takes us back millions of years, to a time when the oceans were ruled by a true titan, the Megalodon, Autodus megalodon. If the shark family were a kingdom, this colossal predator would undoubtedly be king. Roaming the seas between 15.9 and 2.6 million years ago, during the Miocene and Pliocene epochs, the megalodon was a force to be reckoned with. Though long extinct, the very idea of this gigantic shark continues to inspire awe. Megalodon could reach lengths of 45 to 60 feet, with jaws spanning over 6 feet wide. Fossil teeth, some measuring a staggering 7 inches, offer a glimpse into the sheer scale of this marine monster. It's reassuring to know that these giants are no longer patrolling our oceans, though some intrepid adventurers still dream of encountering one. Next, we encounter a creature of undeniable charm, the Dumbo octopus, Grimpoteuthis. Named after the beloved Disney elephant, Dumbo, these octopuses are hardly teased for their large ear-like fins. Instead, they are masters of the deep sea, residing in some of the most extreme environments on Earth. Reaching only about 8 inches in height, Dumbo octopuses gracefully hover above the seafloor, foraging for snails, worms, and other morsels carried by the currents or found near hydrothermal vents. With nearly 17 known species, each exhibits unique variations in size, color, and physical characteristics. The deep sea remains largely unexplored, promising countless discoveries of strange and wonderful creatures. Keep your eyes peeled. The ocean's depths are sure to reveal more fascinating animals in the years to come. Now, let's turn our attention to the sea angel, Gymnosomata. Despite their delicate appearance and ethereal name, these creatures are far from gentle. Their diet consists primarily of sea butterflies, which they ensnare using mucus traps, lying in wait for their unsuspecting prey. A deadly ambush predator disguised as an angel of the sea. Consider the squat anemone shrimp, also known as the dancer shrimp. This tiny crustacean, measuring only half an inch, is known for its peculiar defensive behavior. When threatened, it raises its abdomen above its head and performs a captivating dance. Divers have also observed these shrimp readily hopping onto their hands, acting as miniature cleaning crews. Prepare to be slightly unnerved by the coconut crab, Burgus latro. These imposing crustaceans can reach lengths of up to 3 feet. While their preferred food is coconuts, they are also capable hunters, preying on lizards and even large birds. Imagine encountering one of these giants under the cloak of night. The slender snipe eel, Nemicthus scolopaceus, presents a unique challenge to marine scientists. This elongated fish, reaching lengths of 4 feet, possesses an astonishing number of bones in its spine. At least 750, far more than any other animal on Earth. Its anatomy remains a subject of ongoing research and fascination. The sea pen, Pennatulacea, as its name suggests, often resembles a quill or feather. These colonial marine animals can grow up to 7 feet long and exhibit a remarkable diversity of forms. Many species feature a water-filled bulb that anchors them to the seafloor, completing the pen-like appearance. Prepare to be mesmerized by the Persian carpet flatworm, Pseudobiceros bedfordii. This vibrantly colored creature, though small at only 4 inches long, is a visual masterpiece. Remarkably, it can function as both male and female. Rather than engaging in cooperative mating, these flatworms engage in fierce battles for the right to reproduce. Finally, we encounter the flamingo tongue snail, Siphoма gibbosum. Tourists often admire these snails for their vibrant colors, mistaking the soft tissues covering the shell for the shell itself. In reality, the shell is quite plain and hidden beneath these colorful layers. These snails feed on the toxic tissues of corals, storing the toxins within their own bodies for defense. Do you know where the deepest place in the world is located? It's in the Pacific Ocean, near the Philippines and Papua New Guinea, the infamous Mariana Trench. Imagine taking an incredibly long tape measure, attaching one end to a boat on the surface, taking a deep breath, and plunging into the abyss. Imagine diving into the crushing depths of the ocean, far beyond where sunlight can penetrate. We descend past familiar marine life, plunging into total darkness. After what feels like an eternity, we arrive at Challenger Deep. The measuring tape confirms a staggering depth of 36,200 feet. It's a place of immense pressure and mystery. But hold on, the famous Mariana Trench isn't the deepest point on Earth. Surprisingly, the Kola Superdeep borehole, located in Russia's Murmansk region, surpasses it by a considerable margin. And what scientists discovered there is truly unsettling. As geologists drilled deeper and deeper, reaching a depth of around 9 miles, they encountered inexplicable voids. Scientists on the surface were baffled. They decided to lower a microphone and other sensitive sensors into these mysterious cavities. The temperature readings from below were shocking, a scorching 2,000 degrees Fahrenheit. Then, the microphone picked up something even more disturbing. The recordings captured what sounded like human groans and screams echoing from the Earth's depths. Many began to whisper that the scientists had inadvertently drilled into the underworld itself. Panic started to grip those above ground. Then, according to some accounts, an unidentifiable creature supposedly burst from the drill pipe. It was described as a black, goat-like entity that walked on its hind legs, its form wreathed in dark flames. This being, freed from the deep hollows, reportedly fled into the unknown. Hold on a moment. It's important to note that this dramatic tale originated from a newspaper published on April 1st, April Fool's Day. While many believed it, the story of a demonic creature escaping from the depths is likely a myth. But like most myths, it contains a kernel of truth. The deeper the scientists drilled, the higher the temperature climbed. At a depth of 3 miles, it reached a sweltering 160 degrees Fahrenheit. At 4.5 miles, it soared to 250 degrees. And at the maximum depth of 7.5 miles, the sensors recorded a staggering 400 degrees Fahrenheit. One day, a deafening explosion reverberated from deep within the Earth. Work ground to a halt as everyone tried to determine the cause, but after a thorough investigation, nothing was found. After a pause, they resumed drilling. No further incidents occurred at that depth. The drilling project commenced in May 1970. The initial 4.5 miles were relatively straightforward, cutting through hard granite rock, like drilling through an unyielding wall. But then, the drill encountered softer, more unstable layers. The shaft began to crumble, turning into something akin to drilling through wet sand. Each time the drill was extracted, there was a significant risk that the entire borehole would collapse under its own weight. This eventually happened, forcing the scientists to choose a new direction. What's fascinating is that the final map of the entire borehole didn't resemble a straight line from top to bottom. Instead, it looked like the trunk of a tree, with numerous roots branching out in different directions. 9 years into the project, the scientists reached a depth of 31,400 feet, breaking the world record for the deepest borehole. By 1983, they had pushed the depth another 8,000 feet further. After a short break, disaster struck. A section of the drill string broke off and became irretrievably lodged in the borehole. For months, they tried to recover it, but all attempts failed. Reluctantly, they had to return to a depth of 4.5 miles and begin again. The drill itself was made up of individual sections, each lasting only about 4 hours before needing replacement. In terms of depth, that equated to a mere 32 feet of drilling. The drill was then hauled to the surface, the worn section replaced, and lowered back down. On average, the drilling speed was a snail's pace of about 200 feet per month, the equivalent of digging the height of a 20-story building. In 1990, 20 years after the project began, the scientists finally reached the maximum depth of 40,230 feet. That's like plunging the height of 100 soccer fields straight down into the earth. After another accident, the work was permanently halted. The Guinness World Records officially recognized the Kola Superdeep borehole as the deepest artificial point on Earth. Its depth is equivalent to the height of Mount Everest, with 9 Empire State Buildings stacked on top. One of the most remarkable discoveries at the Kola Superdeep borehole was that the composition of the rock at a depth of about 2 miles closely resembled the composition of the lunar surface. This provided new insights into the formation of our ancient satellite. The theory suggests that in the early stages of Earth's existence, A colossal asteroid collided with our planet with such force that it caused a cataclysmic explosion. A massive chunk of Earth was ejected into space, eventually cooling and solidifying to form the moon we see today. Another surprising find was the presence of gold. The deeper the scientists drilled, the older the rocks became. In layers of rock dating back approximately 2.8 billion years, they discovered fossilized remains of microscopic organisms, sending ripples of excitement through the scientific community. Imagine the thrill, the sheer scientific exhilaration. Back in the early 1990s, a discovery was made that rewrote our understanding of life's origins on Earth. It suggested that life appeared on our planet a staggering 1.5 billion years earlier than previously believed. However, this ambitious drilling project was eventually shut down. Over time, the buildings and equipment surrounding the B-hole were abandoned, fading into the landscape. Today, the site attracts a different kind of visitor, tourists drawn by the enduring myths of creatures lurking in the Earth's underworld. Beneath a rusty lid lies a hole plunging 7.5 miles into the Earth. But the scientists who toiled here never reached their ultimate goal, to penetrate the Earth's mantle. Reaching that would have required drilling down an incredible 44 miles. At a rate of 200 feet per month, that task would have taken an estimated 80 years, assuming no unforeseen setbacks. But the deeper we delve, the more fascinating the discoveries become. A few years ago, scientists unearthed evidence of a colossal reservoir of water, deep beneath the surface. An ocean holding up to 370 million cubic miles of water. This isn't just a puddle, it's a subterranean sea, billions of years old. Dwarfing all the surface oceans, seas, and rivers combined. Picture this, water at a scorching 2,800 degrees Fahrenheit. Yet because of the immense pressure at these depths, it doesn't boil away. Instead, it's trapped within a crystalline mineral structure. This primordial ocean took shape in the earliest days of our planet, when hot lava and space debris were all that existed. But perhaps the most tantalizing prospect of deep drilling is the potential to find living organisms. Imagine life forms isolated for billions of years, holding clues to the very origin of life itself. In Antarctica, scientists have replicated this feat, creating a similar borehole. There, beneath a thick sheet of ice, they discovered an entire lake, roughly half the size of Lake Ontario. While smaller than Lake Baikal, the largest lake on Earth, it's still a significant body of water. The ice above this hidden lake is at least 20,000 years old, and the water beneath has been cut off from the outside world for approximately 15 million years. During drilling, a chunk of ice brought up from the depths yielded a remarkable discovery: an unknown bacterium. Its genetic code showed only 86% similarity to any known living organism. This suggests we've never encountered anything like it before. Could it even be extraterrestrial? It's a possibility, but for now, it remains a theory. What we do know is that these bacteria are capable of thriving in extreme conditions, even in freezing water. The composition of the water in these underground lakes is also unique. It contains far higher concentrations of oxygen and carbon dioxide than we're accustomed to. Combine these conditions with complete isolation, and you have a recipe for life forms that have evolved in entirely different ways. Consider the implications. Studying these deep-dwelling organisms could provide critical insights into whether life might exist beneath the icy surfaces of other planets or moons. Take Saturn's moon Enceladus, for example. Its 24-mile thick ice shell might conceal an ocean, potentially heated by thermal vents. Now let's descend into another realm of mystery: the depths of our oceans. Much of the ocean remains unexplored, shrouded in darkness, concealing strange and wondrous creatures. Occasionally, the ocean reveals glimpses of the bizarre and sometimes terrifying life it harbors. News reports surface of deep-sea creatures washing ashore after powerful storms. Some appear merely strange, while others seem like true monsters, hailing from depths exceeding 300 feet. In the coldest, deepest parts of the ocean, a phenomenon known as gigantism occurs. Sea spiders, squids, worms, and numerous other animals, mostly invertebrates, grow to enormous sizes, dwarfing their shallow water counterparts. Imagine a sea sponge in the Pacific depths as large as a minivan. Then there's the colossal squid, Mesonychoteuthis hamiltoni, lurking in the subantarctic waters. This giant is nearly 14 times longer than the average squid found near New Zealand. Back in 2021, researchers exploring the abyssal zone of the ocean captured images of a giant phantom jelly. This ethereal creature drifted at a depth of 3,200 feet, its tentacles stretching an incredible 33 feet. While it likely feeds on small fish and plankton, this massive jellyfish can descend to depths of over 21,900 feet. How does it survive with limited food at such depths? Scientists are still trying to unravel the mystery. The giant squid, Architeuthis dux, poses even more questions. The largest specimen ever found measured a staggering 43 feet long and weighed nearly a ton. Picture those tentacles wrapping around a car, crushing it like a toy. Down in the abyssal zone, sunlight never penetrates. Sunlight's reach is limited. It simply cannot penetrate the crushing depths of the abyss. Here, where eternal night reigns, algae and underwater plants are absent. The local inhabitants subsist on a peculiar substance known as marine snow. Imagine this snow, not as the fluffy flakes we use to build snowmen, but as a constant drizzle of organic detritus. Tiny particles of dead organisms, fecal matter, and other biological debris drifting down from the sunlit surface. Perhaps even the discarded scraps of a meal from creatures far above. It's a meager existence, but seemingly enough to sustain the colossal beings that dwell in these lightless realms, like the enigmatic giant squid, Architeuthis dux. These deep-sea squids generally forego active hunting. Instead, they patiently lie in wait, their massive forms virtually motionless, until an unsuspecting creature wanders too close to their labyrinthine tentacles. It might not be the most efficient hunting strategy, considering the sparse population in these frigid, dark depths, but it conserves precious energy. A giant squid might consume a mere 1% of its body weight in fish each day. A paltry 4,000 calories. That's nearly 50 times less than the daily caloric intake of an average human. When a giant squid manages to secure a meal, it savors it, conserving the energy for days to come. One can only hope that these colossal cephalopods never develop a taste for surface-dwelling creatures, should their abyssal larders run bare. And, perhaps even more urgently, that the sluggish Greenland shark, Somniosis microcephalus, doesn't get similar ideas. These formidable sharks, denizens of the deep, have been found at depths of over 7,200 feet. They move with glacial slowness, typically swimming at a speed of just over 1 foot per second, about half the speed of a leisurely human walk. This deliberate pace is a key element of their energy-saving strategy, crucial for survival in the resource-scarce environment of the deep sea. However, they are capable of short bursts of speed when the opportunity for a kill presents itself. But more often than not, the Greenland shark adopts the role of a scavenger. In this environment, the rain of decaying matter from above provides a more reliable food source than actively pursuing elusive prey. The Greenland shark is an incredibly slow-growing animal, adding only about 0.4 inches to its length each year. Considering that they can reach lengths of up to 20 feet, it's clear that these sharks live for an extraordinarily long time, sometimes exceeding 400 years. Their slow metabolism is a significant factor in their remarkable longevity. These sharks thrive in frigid waters, an adaptation made possible by specialized chemical compounds in their tissues that act as a natural antifreeze, preventing the formation of ice crystals throughout their bodies. But what allows them to reach such immense sizes? Scientists are still piecing together the answer. One prevailing theory revolves around Bergmann's rule, which posits that larger animals tend to be more efficient at conserving heat. Comparing a tiny minnow to a whale, hundreds of times larger, illustrates this principle. The whale possesses a significantly lower surface area to volume ratio, enabling it to conserve energy more effectively and lose less heat to the surrounding environment. Furthermore, larger animals are capable of consuming larger prey, navigating challenging environments with greater ease, and defending themselves more effectively against potential predators. And, as a general rule, body size tends to increase in colder temperatures, making the Greenland shark a prime example. Consider also the giant sea spiders. Sea spiders are generally quite common, with some species being incredibly small, measuring a mere fraction of an inch. However, in the frigid depths of the Antarctic, they undergo a remarkable transformation, ballooning into monstrous giants with leg spans reaching up to 3 feet. This gigantism is attributed to the higher oxygen content of the cold water, which allows more oxygen to diffuse into the animal's body, fueling its immense growth. A fascinating creature to behold, and a chilling nightmare made real. And what of the giant tube worm? Researchers stumbled upon this bizarre creature during an exploration of the Pacific Ocean floor near unusual hydrothermal vents. These vents are fueled by volcanic heat. As seawater seeps down through cracks and fissures in the Earth's crust, it is superheated by the molten rock below. This heated water then erupts back into the ocean, laden with dissolved minerals and chemicals. Most organisms would perish in this toxic chemical soup, but not these remarkable tube worms. These creatures were a complete surprise to the scientific community. Not only are they unaffected by the toxic chemicals and near-boiling temperatures emanating from the vents, but they have also cultivated entire ecosystems around them. What makes them truly unique is their independence from sunlight. Instead, they rely on symbiotic bacteria as their primary energy source. These bacteria, in turn, derive their energy directly from the toxic chemicals spewing from the vents through a process called chemosynthesis rather than photosynthesis. And, adding to their strangeness, these tube worms lack mouths. The bacteria live within their tissues, providing them with the sustenance they need. A bizarre and fascinating story indeed. And to top it off, these eerie worms can reach lengths of up to 8 feet. The giant isopods are no less unsettling. These creatures lurk in the abyssal depths of the ocean, at depths of 1,600 to 7,000 feet or more, far beyond the reach of sunlight. Resembling monstrous woodlice, they spend their lives scavenging the seabed, patiently waiting for morsels of food to drift down from the higher reaches of the ocean. Note the small hooked claws at the ends of their legs. These isopods use these claws to maintain stability as they navigate the treacherous terrain of the ocean floor. And because there is no light in their world, they rely on long, sensitive antennae to feel their way through the darkness. And those incredible sensory feelers extend about half the length of their entire body. Just imagine the signals they pick up in the inky blackness. Giant isopods also possess remarkably large eyes relative to their body size. These deep-sea dwellers can grow to over 12 inches from head to tail. That's a foot-long bug. These fellas are the epitome of patience. Remember, down in the abyssal depths, meals are few and far between. Sometimes they have to wait years for a proper feast. That's why their metabolism is unbelievably slow. They can go for, get this, 5 years without eating a single thing. Imagine that. I get hungry just thinking about it. Back in 2006, a marine biologist conducted research comparing the differences between shallow and deep-sea regions. What he discovered was fascinating. The deep sea mirrors the island rule. First, isolated land masses develop unique biodiversity, species you won't find anywhere else on the planet. Second, small-bodied life forms in these isolated environments tend to grow much larger than their counterparts on large land masses. Resources are scarce, but so are competitors and predators. The truth is, we still know so little about these deep-sea creatures. It's incredibly expensive and complicated to carry out comprehensive research at those depths. So, for now, we'll have to wait for more raging storms and deep-sea trawlers to give us glimpses of the monstrous world hidden in the cold, crushing depths of our oceans. Welcome, dear listeners, to another enthralling episode of our exploration series. Today, we're plunging into a world closer to us than the moon, yet remains largely unexplored. A world that blankets over 70% of our planet's surface, yet we've only scratched the surface of its mysteries. You guessed it. We're talking about the vast, the deep, the beautiful, and the mysterious. Our oceans. Despite all our technological advancements, we've explored a mere 5% of these underwater realms. To put that into perspective, more people have walked on the moon than have ventured into the deepest part of our oceans, the Mariana Trench. So buckle up as we embark on this fascinating journey, exploring the depths of our oceans, the creatures that dwell there, the unique phenomena that occur beneath the waves, and the monumental challenges we face in uncovering these underwater secrets. Stay tuned as we dive deeper than ever before into the mysteries of our blue planet. Let's pause for a moment and truly consider the immense pressure and crushing depth we're dealing with. It's easy to forget, standing on the shore, watching the waves gently lap against the sand, that beneath that tranquil surface lies a world as alien to us as the surface of another planet. Imagine, if you will, descending into the ocean. As you go deeper, the sunlight fades, gradually replaced by an all-encompassing darkness. The weight of the water above you increases exponentially, and with it, the pressure. This isn't just a metaphorical weight on your shoulders, it's a literal crushing force. At the greatest depths, the pressure is so intense that it's actually harder to send people to the bottom of the ocean than to send them into space. Yes, you heard that right. Space, the final frontier for many, is easier to reach than the abyssal depths of our own oceans. In space, as we ascend through Earth's atmosphere, the pressure drops to near zero. But in the ocean, it's a completely different story. The deeper you go, the greater the pressure becomes, reaching levels 1,000 times greater than on land. It's like having hundreds of elephants standing on your head. It's a world where human beings, as we are, simply cannot survive unaided. Yet, despite these extreme conditions, life thrives. Creatures of the deep have adapted to survive in this high-pressure environment, leading to a biodiversity that is as stunning as it is surprising. But for us to explore these depths, we need to overcome incredible engineering challenges. We need to build machines capable of withstanding these pressures, and we need to find ways to protect ourselves from the crushing weight of the water above us. As we delve deeper into our exploration, we encounter a fascinating phenomenon: the shifting of oceans and continents. The Earth, as we know it, hasn't always looked the same. Over millions upon millions of years, the continents have drifted apart and collided together in a slow, majestic dance, orchestrated by the movements of the Earth's crust. The Atlantic Ocean, for instance, is a testament to this incredible geological process. It was formed when the North and South American continents separated, creating a vast body of water in between. And even now, it continues to grow, expanding at a rate of about 2 inches per year. On the other hand, the Pacific Ocean, the largest and deepest of Earth's oceanic divisions, is slowly shrinking. This constant, albeit slow shift in our planet's geography is a stark reminder of the dynamic nature of Earth. These movements not only shape the physical landscape of our planet, but also profoundly influence the distribution and evolution of species in our oceans. The shifting continents have created diverse habitats, leading to the evolution of a myriad of marine species.